All right, welcome to my first CNC video. This is my 5-axis CNC that I'm building. Just gonna give like a quick overview of it in the CAD before I show you what I've built in person. Um, it's relatively simple, you know. Uh, so I'm just gonna kind of work or show you what I got going on here. So essentially, it's a 3-axis CNC up top. So in this area, this is pretty much all 3-axis, and then this is where your other 2-axis come for your 5-axis in total. We're going to start with just a 3-axis. So my plan is just to build a complete 3-axis at the beginning. And after I have the 3-axis built, then I'll add on the 2-axis down here later, just trying to minimize error and issues that I might have. And so the goal with this CNC is going to be almost 100% 3D printed, like as much as I can. Obviously, like linear rails, lead screws, stuff like that. I'm not going to have 3D printed, which in theory you could do that, but that just sounded a lot harder than I wanted to make this. So maybe in the future I'll make another one, another version of this, uh, similar to that, but for now, I'm just sticking with mainly 3D printed. But anyways, let's jump into this. So this is going to be um your spindle holder. So this is a spindle. This is a 800-watt spindle. It's the same size as like your normal Chinese 500-watt spindle that you would just buy for like a DIY spindle kit. It's air cooled. So I've modeled that and then used this as a placeholder. So it's got two brackets that hold it on here. It's got some bolts that hold this. And then this whole mechanism here and here, this blue part, attaches onto these linear guides right here. So these are just on a rod with a bearing inside. I don't have everything modeled. This is just like the general size, just for a placeholder. Um, so that hooks on here, so these just bolt straight into these blocks right there. And then back here, it's kind of hard to see, but you have a lead screw, which underneath here's a brass nut coupler. So this is what makes the whole mechanism, go up and down uh, as we're doing our work. You got some pillow block bearings, so this is for the lead screw, just so there's not as much torsion on it. And then up here, this is a NEMA 17 motor that I have. It'll be connected to this lead screw here. And then this whole piece, oops. Oh, I forgot to mention that these two things are all 3D printed. It makes pretty easy accuracy, so I'm not going to have any issues with like having to drill out holes or stuff like that. And then this piece will also be 3D printed. Um, and to get my rods in here, I have a little threaded hole here. So you can see right here, here's the threads. So the rod just slips through here, and then I screw in this cap just to lock them into place. And then on this side, I have just a little place for them to slip in, and then it just meets the end, and you get your pressure fit from this screw right there. So these are 3D printed threads as well. It's kind of interesting, kind of cool. Um, and then it's kind of really hard to show. We're just gonna move this back. So I think it's something like that. But this whole back plate right here, this all gets mounted onto 4 more linear bearings. These 4, and then 2 on the bottom, which you can kind of see right there. So this whole thing will allow this to move in this axis, and then the whole spindle will also move with this blue piece. So that will give it your 2 axis, and then So while it's moving side to side, this can move up and down. And then that's just attached similarly to the z-axis over here, where it's got uh, a linear rod going through it, as well as a lead screw, which it's connected to. And then kind of hard to see, but it's also got pillow block bearings. And then it's also got some more pillow block bearings over here. Hopefully I'm not disorientating you too much, but just trying to show what it'll look like. So now to the kind of main piece. This is the largest piece. This will be, I like to call it the z-axis. It could be the x or the y. Or sorry, I like to call it the x-axis, not the z-axis. This could be the x or y-axis. I typically call it the x-axis, but so this whole piece is going to move this in this direction. Let me get a better view here. So this whole piece is going to move back and forth, which will carry everything else that we've looked at so far. So that will give your third axis. And how this is all connected is got these bearing blocks, so you'll screw in from the outside into here. These should be lined up here. I just don't have that for, I guess I could do this, maybe, no. Anyways, that should be lined up. So these holes, for instance, this hole would be lined up with this hole right here. And that's how that would work. And similarly to the z-axis, I have this, whatchamacalls it? Sorry, I'm blanking for words. A threaded insert here. So you'll insert this as your rod slides through. So that way it can be assembled. And then same thing on the other side as the z-axis, where it's just kind of, you can't see it, but it's just these rods will slide into the piece here. So that's kind of how that works. So then right now this is all just floating in the air, but these mounts will actually mount onto a piece of wood temporarily. That's just to give it some stability, and it makes it pretty easy for me to print. There's not much big items. It's pretty stable. There's no having to connect multiple 3D prints together, So this is what this would look like. There will be four plywood sheets around the machine. So this would just bolt straight in. There'll be a nut on this side. And I'm actually going to cut out this piece right here on my CNC that I already have. My 3-axis is a lot larger than this. So I'll just cut out these so all the holes should be nice and aligned and everything should just fit perfectly. So again, there's 4 mounts. I just had to make sure that at the maximum spot that we are going to be clearing. So you can see there's, I think, like a millimeter or 2 gap here that I'll have to be clearing. So that's pretty much how that's looking. Again, another NEMA 17 stepper here on the Y gantry going this way. And then let's look at the X gantry. So this is actually dual lead screw. And I forgot to mention, each of these lead screws are going to have anti-backlash nuts. So there should be no backlash in theory, or very minimal. There's always going to be backlash, but it should be very, very minimal. But this is driven by 2 NEMA 17 motors, which will be on the outside. So let's see here. Where's they at? So we got 2 NEMA 17 motors that are gonna screw into, well, I'll take a bolt through the wood and into the NEMA 17 motor. So that's how those will mount there. There will be a coupler between here and this lead screw. So that's how I'll get that. And then I also have not modeled this yet. I accidentally cut off these bearing blocks, as you can see, but they should be full-size bearing blocks like this. But I'm just gonna have to make a spacer in between the wood and here, so that way everything can line up, but that should be pretty easy. And you can kind of visualize what that would look like. And that's pretty much it for the 3-axis. I had to do a little pocket here so that way we weren't hitting our motor. You can see there's quite a few more holes. And then to make this the 3-axis, I've actually included a little piece of plywood here as like my build surface, like a sacrifice area essentially. And that's just hooked on by 2 bolts here, and then I'll screw into the wood from the bottom. So these will go all the way around, so you can see all these double holes are where each of those will be. So we'll have like what, 4, 6, 8, and then I have a door, but I think I'm going to redo this door so that way you can see inside of it. So yeah, that's kind of the 3-axis portion of this. Let me just get rid of these walls, that way we can see a little better. So now if we look at the 5-axis portion, this is a little more complicated, I would say, than the 3-axis, or maybe that's just because I'm more versed in 3-axis. So I think I will end up redesigning this just because I don't really like how it's made right now. I'm not a huge fan of this, and there's going to be, I have a gear here. Will it show? Let's see here. Where's it at? Where is it at? Don't know. Anyways, there's going to be another gear here that will mesh with this one. So it'll be a 45 and be flat here. That's the current idea. That's going to have a lot of backlash, I already know, and it's not going to be very strong. So I'm looking into some different anti-backlash options, specifically like sequential drives or harmonic drives, but I want those to be all 3D printed, and it's really hard to get good tolerances that will hold up to, the load that a CNC would have. So I'm also looking at some other things like belt-driven options. It has to reduce it because this is going to be quite a bit of torsion for a little NEMA 17. So if you have any ideas, make sure and drop those in the comments. Very interested to see what you guys have to say about this. But basically, this is just I call it a turn-on table. I think that's kind of what it's called. I'm not 100% sure. But essentially, this whole thing is going to move this direction. So it'll rotate like this. So essentially what that'll do, where's my work at? Actually, I could just do this, right? No. Nope. Okay, sorry. Essentially, the red piece here is going to be the work, and that's just going to rotate around like this. So you can see you can get kind of all different angles from here. And then on top of that, this chuck is also going to spin from this NEMA 17 motor here. And that's going to allow this workpiece to rotate around like this while also spinning like this. So that essentially lets us get into basically every nook and cranny you'd want to get into. So that really increases what we could do on our CNC with just one tool path. So we're not having to reposition the work. It's just we can just what do you call it? We can basically just make one cam without different work offsets. I guess that's how I want to say it. I'm not sure. Essentially, how this works is just a 3D printed chuck that I found, and it's gonna have some washers here. This is a bearing. Oops, that was not what I wanted to do. Anyways, there's a thrust washer here that goes into a bearing in here, and then another thrust washer on top. This is probably not the most best use of these bearings, but I think it should work. And then it's going to be the same thing over here. We're going to have a actual like a skateboard bearing inside with a thrust washer bearing on the outside. And then same thing over here. This one is just going to be kind of the floating end, so there's not going to be anything driving it. Whereas on this side, it's driven by a 8 millimeter bolt that runs through here, and then I'll just connect to the bolt on the outside and run that via the stepper motor on the outside of like one of these boards on the other side. I haven't completely worked out how that's gonna work. I probably will try enlargening this somehow. Not sure how that's gonna be done, but that's the plan. And yeah, that's pretty much how this whole thing works. Just kind of get a nice little overview of everything. Um, but yeah, if you have any questions, feel free to drop them in the comments below and I'll try and answer. And I'm going to be posting more. I've actually got most of this stuff printed and it's just now assembling it. I'm starting making these videos a little behind of what I should have. So it's going to be a little interesting the first couple of videos. I'm going to try and video my work as I go from now on. But this is just how we're starting it. So hope you enjoyed and hopefully see you in the next one. Bye.